Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today we're going to be doing Unit 8, Lesson number 2 on solving square root equations. So, because square root functions come up a lot in mathematics and in science, it's good to be able to solve equations that have square roots in them. Now, we kind of saw this a little bit when we worked with both the distance formula with the equations of circles and when we worked with the locus definition of a parabola. But now we're going to really formally take a look at how we solve square root equations. We're also going to see something for the first time in this course known as an extraneous root, which is kind of cool. But let's jump right into it and learn how to solve equations involving square roots. Now, the simplest type of equation, of any type, is one where x shows up only once. And remember, even back in Common Core Algebra 1, the way that we looked at equations where x showed up only once was basically saying, let's undo what's been done to x. So in the simplest of all scenarios, we have the square root of x equals 7. Now, in order to undo the square rooting, we will do the opposite of square rooting, which is squaring. And root x times root x is just x. And then, of course, 7 squared is 49. Now, I don't think you need much of a procedure to know that. But that's kind of the basis for everything we do, right? We know that square rooting is the opposite of squaring, so squaring must be the inverse or opposite of square rooting. Now, when we look at letter B, we might get confused. We have the square root of x minus 3 equals 5. Should I add 3 first? Should I square first? And of course, it'll make a difference. Well, again, this is an order of operations issue. If we were to actually evaluate this, the first thing that we would do is subtract 3, and then we would take the square root. So, to undo them, the first thing that we're going to do is square, and the second thing we're going to do is add 3. All right, so let me just kind of get rid of this. Let's do it. Let's square both sides, and that's going to give me x minus 3 is equal to 25. And then let's add 3 to both sides, and we'll get x equals 28. Now, notice it says check each equation, because you can. Literally, we can make sure that this is a solution to this equation by just making sure that it makes it true. Right? If I put that 28 in, right, I'll first do 28 minus 3, which is 25. Square root of 25 equals 5. Yes. Now again, keep in mind that these are all positive square roots because there is no negative sitting in front of the square root sign. All right, take a look at letter C. Okay, obviously we've got some more of these in exercise 1, but we'll bring them up on the next page. Think about your order of operations here, what's been done to x, and what you have to undo in the proper order. Pause the video and think about that a little bit. All right. Well, the plain fact is, right, we've taken x, we've multiplied it by 2, that's here. Then we've subtracted 1, that's there. Then we've taken the square root. So to undo them, I'm going to square first, then I'm going to add 1, and then I'm going to divide by 2. So let's do it. Let's square both sides first. That gives me 2x minus 1 equals 16. Then, of course, we'll add 1 to both sides and get 2x equals 17. Divide both sides by 2 and get x equals 17 halves, or 8.5. All right, and that's really it so far. All right, we'll look at three that are a little bit more complicated in a second, but pause the video now and copy down anything you need to. All right, let's clear out the text and do some that are a little more complicated, but not really. And the reason I say that these aren't that much more complicated is, yet again, x shows up only once. So I should be able to just walk through them, figure out order of operations, and solve. In fact, let me ask you to pause the video now, take up to maybe a little bit more than 5 minutes, and solve these 3 problems. Okay, let's go through them. Now letter D, this one's still pretty simple. I'm not going to list these things out anymore. I took the square root, then I multiplied by 3, then I subtracted 4, and I got 20. So the first thing I'm going to do to get x all by itself is I'm going to add 4 to both sides. The next thing, I'll get rid of that multiplication by 3. I'll get root x is equal to 8. And then I'll square both sides. And I'll get x is equal to 64. There we go. Now these two, especially letter F, are more complex. But still, let's take a look. We had x, we added 5. Then we took the square root, then we multiplied by 2, then we added 7. So let's get rid of that 7 first. Okay, let's get rid of the multiplication by 2. Then let's square both sides. And then let's subtract 4. Let's subtract 4. How about let's subtract 5? And we'll get x equals 4. All right, last one. We took x, we multiplied by 3. We subtracted 2. We took the square root. We multiplied by 5, and we subtracted 4. So we're going to add 4 to both sides. Right? So we have 5 times root 3x minus 2 is equal to 40. Now we'll get rid of that multiplication by 5 by dividing both sides by 5. That'll give us 3x minus 2 under the square root is equal to 8. All right, now we'll square both sides to get rid of the square root. 3x minus 2 is equal to 64. Add 2 to both sides. 3x is 66. Divide by 3. And x is 22. Ooh, I like that one. Doesn't it look complicated? I mean, it looks just absolutely horrible, and yet at the end of the day, all we are doing is undoing what has been done to x. This will be a little bit more complicated later on, but not that much. So pause the video now and write down anything you need to. All right, let's clear it out. Exercise number 2. Which of the following is the solution to this equation? Pause the video now and try to come up with the solution. Okay, now I'll concede the fact that you could just check all of these, plug each one of them in. But let's do it the old-fashioned way. Let's just solve it. Now remember, this isn't the cubed root. This is a 3 times the square root of x over 2. So I've got x, I've divided by 2, taken the square root, and then multiplied by 3. So the first thing I'm going to do, let me rewrite the problem down here, is I'm going to undo the last thing I did, which was that multiplication by 3. So I have root x divided by 2 is equal to 5. Then I'm going to get rid of the square root by squaring each side, and getting x divided by 2 is equal to 25. I'm then going to multiply both sides by 2, and get x equals 50. Choice 3. All right, that's it. So when we've got, if you will, linear square root equations where the x is only raised to the first power, they tend to be pretty easy. We're going to go on now and take a look at some problems that are a little bit more challenging. So pause the video now and copy down anything you need to. Okay, here we go. All right, exercise number 3. Consider the system of equations shown below. Solve the system graphically using the grid to the right. All right, let's solve a system graphically. Now, you could definitely do this using tables on your calculator, but I think you can do it without your calculator. Maybe, maybe not. Pause the video now and either use your calculator to generate tables of values or sketch by hand using transformations and other facts that you know. It's up to you. But pause the video now and solve this system algebraically. I mean graphically, sorry. All right. Well, here's why I think you can even do it without a calculator. This is just a leftward shift by 3 units of this thing. So if I do that, 1, 2, 3, 4, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3. Right? Here's my y equals root x plus 3. Remember, especially if you're in New York State, label all your equations. Right? This thing is simple enough. That's just linear, right? With a slope of 1 and a y-intercept of 1, no issue there. In fact, I'm going to take advantage of the fact that it's linear and just do this. All right, but again, label it with its equation or you lose a point, which could be quite a bit. So, solve the system. Well, solving a system graphically means to just find its intersection point, which is 1, 2. Now, letter B says solve the system algebraically for the only x values using substitution, for only the x values using substitution below. My bad. All right, so I want to solve the system, but I'm only gonna do it for the x value. So what I'm gonna do is I'm gonna take my x plus 3 and I'm gonna substitute it in for that y. Now, unlike the problems on the front side of the sheet, here x shows up more than once. So generally when that's the case, what you do is you try to isolate the square root quantity, and we'll do that a little bit more in the coming problems. And once you've got the square root isolated, like it is here, you simply square both sides. Now this can be visually tricky for kids. Here, root x plus 3 times root x plus 3, by definition, is just x plus 3, because that's what happens when you square a square root. On the other hand, over here, we've got a little bit more work to do, right? Now, some of you know how to just multiply this kind of stuff out in your head, but, you know, we generally have to FOIL, and we'd get something like that. Now, notice what we have. Step back for a moment. What we have now is a quadratic equation, and this is where you can't lose your confidence. You know how to solve equations with x squareds in them. We typically use the zero product law, or we could use the quadratic formula, a variety of different things. Now I know we haven't reviewed the quadratic formula this year, so I'm sticking with the zero product law. So I get x plus 2 times x minus 1. X plus 2 is 0, which gives me x equals negative 2. And x minus 1 equals 0, which gives me x equals 1. Well, that seems a little odd. And letter C gets at what's odd about this. It says, why does your answer from part A contradict what you found in part B? Well, there should be only one solution. And that one solution is this one, right? There it is, x equals 1. The y equals 2 is just the fact that the y is equal to 2. But algebraically, we found 2, right? 1, 2. And that certainly seems to contradict what we're even looking at here. We should have only gotten 1 when we solved it algebraically, and yet we got 2. This root, this one here, is what's known as an extraneous root. All right, it's an extra root. In the next exercise, we'll kind of take a look to see how we can tell when a root is extraneous or not. But in this problem, we can tell it's extraneous because it simply isn't the intersection point on those two graphs. It's just not there. They do not intersect at x equals negative 2. I mean, at x equals negative 2, this one's up here and this one's down here, right? They're not equal at that point. And we will explore that a little bit more in exercise 4. And in a later lesson, not even in this unit, we'll even explore why extraneous roots arise. They're irritating though. When you look them up on Wikipedia or other results, it often just defines them as, roots that are valid for further sort of steps of an equation, but not for the original equation. Anyway, whatever. Look it up on Wikipedia. It's kind of cool. Pause the video now and write down anything you need to. Okay, let's clear out the text. And let's tackle a square root problem. I know that I had these two equations on the same sheet, but I want lots of room. So let's take a look. It says, find the solution set of each of the following equations. Be sure to check your work and reject any extraneous roots. All right, fair enough, no problem. Let's take a look. Okay, so what we've got here is we've got the square root already isolated. Now, by isolated, I mean I don't want anything else on the same side as the square root, just that. But once we've got it isolated, then it's easy enough. We can just square both sides. All right. Now, when we square this side, we just get 2x minus 3. This side's a little bit more work. I have to FOIL it, so I'll get x squared minus 3x plus 9. Real important that that's plus and not minus. Let me combine some like terms on the right-hand side. We'll get x squared minus 6x plus 9. And again, this falls into the same category as the last one. We've got an x squared, so I want to try to use the zero product law, which means I've got to bring this negative 2x over to this side, and I have to bring this positive 3 over to this side. And what I'll get is 0 equals x squared minus 8x plus 12. Now, I can factor this trinomial as x minus 2, x minus 6, great, and I'll get x equals 2 and x equals 6. Now one of those is an extraneous root, and we can figure it out by doing a check. All right, so let's check x equals 2. All right, let's throw it in here. We get 2 times 2 minus 3 is equal to 2 minus 3. That's going to be the square root of 4 minus 3 is equal to negative 1. Square root of 1 equals negative 1. Now, some people might look at that and go, sure, because there's two square roots for 1, negative 1 and positive 1. The problem is this is only the positive square root, so this is false. And because it's false, this one, let me go in blue, gets rejected because it's extraneous. Let's check x equals 6. Let's do that one as well. Maybe they're both extraneous. All right, here we'll have the square root of 2 times 6 minus 3 is equal to 6 minus 3. I don't know. We get square root of 12 minus 3 is equal to 3, and the square root of 9 is equal to 3. Well, in this case, it's the positive square root, so 3 equals 3, and that's true. So that is a correct answer. In fact, it's the only correct answer, the only one. All right, so you can always find extraneous roots, if they exist, by substituting in your final answers and checking. And they often will exist when you have square root equations. All right, pause the video now, check your work, and then we'll do one more. All right, I'm going to clear out the text. Let's do another one. Now, I'm kind of tempted to have you do this one on your own. All right, and I do want you to pause the video for a minute to think about just what your first steps would be to solve this problem. All right, well, for me, the first step I always want to do is isolate the square root. Get it by itself. Now, over here, this 2, I can't really have it because it means that that square root isn't isolated. But once I've isolated the square root, well, then the next step will be to square. Now on this side, it's no issue. It's x plus 6. But again, 2x plus 2 times 2x plus 2, what would I have? I'd have 4x squared plus 4x plus 4x, whew, plus 4. Do you love all the 4's there? It's because of all the 2's here. Let me clean that up a little bit. 4x squared plus 8x plus 4 equals x plus 6. Again, I've got a quadratic. And here is the one I'm going to solve according to the zero product law. Now, we could guess and check, as much as you want. But these are the correct guesses. 2 times 4 is positive 8. 1 times x, negative 1 times x is negative x. This is mine to be 7. All right, so what do we get? From this one, we get x equals 1/4. And from this one, we get x equals negative 2. And now we should check them. All right, don't reject things because they're negative or because they're fractional. Reject them because they don't check. And I'm going to check them in the original equation. So let's check x equals 1/4. Well, let's try. I know it's a fraction. Nobody likes fractions, but we'll get 2 times x equals the square root of 1/4 plus 6 minus 2. And I know you're looking at this now probably going, oh, why? Well, anyway, 2 times 1/4 is 1/2. That's no problem. But what am I supposed to do here? Well, I got to get a common denominator. You guys know that with fractions. So that's 24/4. But then when I add it to 1/4, I get 25/4 minus 2. All right, the square root of 25/4 will be 5/2 minus 2. And you could do some of this on your calculator. Obviously, I'd have 5/2 minus 4/2, which would be 1/2. Oh, so the 1/4 is a good root. Well, at least checking x equals negative 2 probably won't be as bad. Well, let's take a look. 2 times negative 2 equals the square root of negative, that was a mistake. Square root of negative 2 plus 6 minus 2. That's going to be negative 4. Over here, negative 2 plus 6 is positive 4 minus 2. Square root of positive 4 is 2. And negative 4 equals 0. No. So that is my extraneous. Okay. And that's it. Now, again, in a later lesson, we're going to see extraneous roots again. And we'll even seek to understand why they arise. What was it about this? Even though we followed the golden rule of algebra, right? What you do to one side of the equation, you do to the other. That's exactly what we did every time when we had extraneous roots. And yet somehow we ended up with answers that weren't correct. Weird. All right, but we'll eventually explain it. For now, pause the video and write down anything you need to. Okay. I'm going to clear out the text, and let's wrap up the lesson. So in this lesson, we solved pretty simple square root equations, nothing all that complicated, all right? But some of those square root equations gave rise to these extraneous roots, values of x that we didn't do anything wrong finding. We did every step of the solution correct, but then they don't check. Those are very weird, very weird. Thankfully, they don't come up a lot in algebra, but they do come up a little bit in this course. All right. I want to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.